Alrighty. Like I said yesterday, fortunately I can't be here today. I have to take James to the doctor. But happy Tuesday. We're going to start off with a problem from yesterday. We're going to look at on page 4. We're going to flip to number 3. We skipped number 3 yesterday, so I'm going to have you do that to start. Okay, so pause it. Give that one a shot. Let's see if I can just... There we go. Here's my work for number 3. Okay, here's my work for number 3. If you want to check yours, I got 477.57 for number 3. I know the wording of this is not great. Okay, from a point that's 405 feet away from the monument is not great. All right, but let's talk about something new today. So we're going to talk about the law of sines. All right, we're on page 5, day 2, law of sines. There are 2 forms for the law of sines. This one and this one. They're reciprocals of each other. We will use mostly that one on the left, but it's the same thing as the one on the right. If you just look at that formula right away, you'll notice that there's 2 equal signs in there. Obviously, we can't have 2 equal signs to solve a problem, so we'll only use 2 of those 3 fractions to help us solve. Okay, 2 out of the 3. The law of sines can be used to help you solve a triangle if the triangle is oblique. Basically, we're solving a triangle for its missing sides when I have a triangle that is not right. In order for it to be used, I need 2 sides and an angle. All right, 2 sides and an angle. It can be angle, side, angle, or angle, angle, side. You need 2 angles. 2 angles and a side, not 2 sides and an angle. 2 angles and 1 side. 2 angles and 1 side, and that tells you that you have to use the law of sines. Lowercase side lengths will be represented by lowercase letters, and angles will use upper. So what I mean is side A is always going to be across from angle A. Side B is always going to be across from angle B. And then side C will always be across from angle C. I know that was different when we talked about, or sometimes it was different when we talked about right triangles. I said when we solved the Pythagorean theorem that A and B were interchangeable. Here they are not. It all depends on the angles. So we're just going to solve for side A in number 1. Okay, we're just going to solve for side A in number 1. So I notice that I have angle A and angle B. This 24, that is side C. So I need to figure out, okay, what's angle C? Well, angle C is 180 minus 118 minus 22 is angle C, which is 40 degrees. So my setup will always look like this. Sine of an angle over a side equals sine of an angle over a side. Angle C must be in the same ratio as side C. Okay? So if angle C is 40 and side C is 24, they must be in the same ratio. Angle A is 118, and I want to find side A. So I put the 118 there, and I have side A right here. From there, it's just solving a proportion. This is what we did last unit. All right, we know how to solve proportions. A fraction equal to a fraction. I cross multiply. I have A times the sine of 40 equals 24 times the sine of 118. And don't put anything into your calculator yet. Wait until the end. All right, this is just like trig kind of at this point. Like, how do I get A by itself? Well, to get A by itself, I need to divide both sides by the sine of 40. And then A will be by itself. This right here, what I'm about to highlight, is what goes in your calculator. All right, how that looks, I will show you. So I do 24 times the sine of 118 divided by the sine of 40. Oops. 40. Just like that. Okay. I could do sine of 118 times 24 divided by sine of 40, and I'll get the same thing. All right, but it has to be divided by a sine of 40 at the end. Don't put it just at the beginning. Okay, it's both of those things. The sine of 118 times 24. That all is being divided by the sine of 40. So I get 32.97. Whoops. A 32.97. Okay? Let's go solve for A number 1. Number 2. Let's try number 2. If you have questions throughout this video, make sure to write them down. All right, and I'll take those when I get back. So angle B is 30, so side B is 22. Angle A is 50, and I'm trying to find side A. So I'll start off sine of equals sine of. Well, since angle B is 30 and side B is 22, those should go in the same ratio. I'm trying to find side A, so I need the 50. We are going to find side C in this one. We are going to find side C in this one as well. Here, just cross multiplication. A times the sine of 30 equals 22 times the sine of 50. Divide sine of 30, divide sine of 30. I got Scottie Pippen. A equals 33.71. All right. To find side C, I need to know angle C. Well, angle C is 180 minus 50 minus 30 to get 100 degrees. I can also use the sine of B over B again. I could use the sine of A over A since I know what the side A is, but I'm going to use B in this case because side B is a whole number. It's not a decimal. If you used the 50 and 33.71, your answer might be a couple decimal points off. That's not the end of the world, but that's why you may get a different answer. Just show your work and I'll make sure to follow it. And then I just cross multiply and solve from there. Hopefully we're getting better at this. I mean, the trickiest part probably is just the setup, and then the cross multiplication shouldn't be too bad since we did a ton of that last unit. For C, I got 43.33. All right. I would like you to pause it, and why don't you try numbers 3 and 4, okay? And then I'll check these tomorrow. If you have questions on 3 or 4, I will answer them then. But these are my numbers here, so you can check your work. And that way, if you do have questions, you can ask them tomorrow at the beginning of class. I think this was 7, 8. This should be 100 degrees. All right. Try those two, okay? And then tomorrow we will talk at the beginning of class, or excuse me, on Thursday we'll talk at the beginning of class about those two if you have any questions. Okay? Once you're done with this, why don't you try your big ideas homework.